Good viewers, this is Afia Ademola Johnson, your science tutor. Please try to share this video, subscribe, click the subscription button, and put in the comment section anywhere you have issue. Now today we are looking at chemical equation. Chemical equation. So a chemical equation is a set of mathematical expressions, okay, mathematical statements that represents a chemical change. So, a chemical equation has two parts which are separated by an arrow. So the right side, let's talk about the left side of an equation where the reaction begins is called a reactant. While the right side of the arrow where the reaction ends is called the product side. So we can say A plus B equals to C plus D. This A plus B is the reactant side, while this C plus D is the product side. So take note of that. What are the rules for writing a balanced chemical equation? Number one, the symbol of a molecule of free elements must be written with respect to their atomicity. E.g., hydrogen should be written as H2, chlorine should be written as Cl2, oxygen should be written as O2, sodium should be written as Na, helium should be written as He, aluminum should be written as NaL. So we because atomicity is very important here. I told you elements whose name end in gene, the atomicity is 2. Those elements whose name end in chlorine, atomicity is what? 2. Gene, oxygen. Those ones whose name end in ion, like sodium, helium, aluminium, and on, like carbon, the atomicity is 1, and it should be written like this. If the elements are standing alone on their own, in uncombined state, that's the way they should be written. Now, number 2, the correct chemical symbol of a compound should be written. So don't write another formula that is different from what you do there. Now, number 3, to balance a chemical equation, only their molecular number should be altered and not their atomic numbers, not their atomicity, not their atomicity. So don't touch their atomicity, don't touch the number that constitutes their atomicity. Don't touch any number here, but you can balance from here. Take note of that. Now, there are different types of chemical reaction that will now, so for you to write a balanced chemical equation, you must have the knowledge of the reaction that you are dealing with. So that will make me to digress a little. Types of chemical reaction. Types of chemical reaction. We have some reaction called direct combination. Direct combination. I will just let's look at the example. Direct combination reaction. E.g., the reaction between oxygen, between hydrogen and oxygen to form water. Reaction between hydrogen and oxygen to form water. How do we represent that equation? Reaction between hydrogen, the symbol of hydrogen is H2. If you like, you can put a small bracket and put G, which means the state of matter hydrogen is, which is gas. It's reacting with oxygen. Any gene element is O2, is this. Then what is it giving us? Now it's giving us water, H2O, which is liquid. Then having done that, now a chemical equation must be balanced. The number of atoms at this side must be equal to the number of atoms at this side. Hydrogen is 2 atoms here, hydrogen is 2 atoms, so the hydrogen is balanced. But oxygen is 2 here, but oxygen is 1 here. You cannot say because of this you come and put 2 here, you have altered the atomic number. You have altered the atomicity. So you can only put anything here, and anything you put here will affect all the elements here without even putting brackets. See, if you have 2 oxygen here, you put 2 here. When you haven't put 2 there, it means 2 times 2 hydrogen is 2. But 2 times an invisible 1, 2 times 1, oxygen is balanced. But hydrogen now is now 2 times 2, 4. So you have to put this 2 here now to balance this hydrogen. So the equation is balanced. Another example under that, the Haber process. which involves the reaction between nitrogen and hydrogen to form ammonia. You must have the knowledge of the reaction that you want to write the equation. If you don't have the knowledge, that is why I'm going to I'm discussing this alongside with the types of reaction we have. Now, reaction between nitrogen. Nitrogen is N2, any element, gene element. So, and it's a gas. With hydrogen, hydrogen is also a gene element. Ammonia is NH3, it's a gas also. So here, nitrogen is 2, but nitrogen is 1 here. What would I do? I'll put 2 here. 2 nitrogen is here. But the 2 I put here has affected hydrogen. 2 times 3 is 6. So what do I do to turn this one to 6 also? I'll put 3 here. 3 times 2 is 6. So equation is what? Balanced. Another one here, direct combination reaction. Reaction between sodium and chlorine to form sodium chloride. Sodium is Na, don't forget, it's a solid, it's a metal. Any elements whose name end in ion, atomicity is 1, so no need of putting anything here. Chlorine is in element. Elements whose name end in in, you have to put 2 here. Then sodium chloride, we have discussed that sodium chloride is NaCl. It's a solid. The salt you put in your soup is solid. So that's the formula, sodium chloride. So you can visit our previous video on compound to see how we formed this compound NaCl. So now, but here sodium is 1 here, sodium is 1 here, sodium is balanced. But chlorine is 2 here, chlorine is 1, so we have to put 2 here. So the 2 we have put means chlorine is 2, then but sodium is 2. So I have to also put 2 here now to balance sodium. So the third example here, let's look at the reaction between carbon 4 oxide and water to form trioxocarbonate 4 acid. The formula for carbon 4 oxide is CO2 and it's a gas. The formula of water is H2O and it's liquid. Then combining them together. Write this H2 first. Then this C second. Then O2 plus 1, that's 3. Is aqueous. Aqueous means water has been added and it can dissolve in water, H2CO3. It's already balanced by itself. So that is that about direct combination reaction. Now, let's look at another example. Apart from direct combination reaction that we have, let's talk about number 2 type of reaction, which we talk about, which we say decomposition. Decomposition reaction, in which A plus AB will break down to form A plus B. AB will break down to form A plus B. So, but this one is what? A plus B will combine together to form AB. That is direct combination. So opposite of it is decomposition. So only one bigger compound will split to form smaller ones. Let's look at example. Examples are 1, thermal decomposition of 1. Hydrogen peroxide. 2. Potassium trioxochlorate 5. 3. Calcium trioxocarbonate 4. So the first one is hydrogen peroxide is H2O2. It's a liquid. If it decomposes, it forms H2O, liquid, and what? Oxygen gas. So you must have the understanding of the reaction you are dealing with. That is why I am discussing what? Types of chemical reaction, which is supposed to be SS2 topic, alongside with this balance to make you understand what you are doing. Now here we have 2 hydrogen atoms. So hydrogen atom is balanced. 2 oxygen, but 1 plus 2, that's 3. What do I do? Now, what do I do? In mathematics, the knowledge of mathematics comes in here. I can do something here. This is 2 hydrogen. I can turn this thing to become 1. So that when I add 1 plus 1, it will now give me 2. Then what number can I put here? That when I multiply to this one will give me 1. That is the half of this number. That is 1 over 2. So that when you put, so if I put 1 over 2 here, so 1 over 2 times 2, that's 2 here, 1, 2 here is cancelled. So the equation is balanced. If you don't like it like this, in mathematics, you can linearize this equation by multiplying both sides by what? The denominator of this equation. So that you now have 2H2O2 liquid giving me 2H2O liquid plus what? O2. Because here now, 1 over 2 times 2, the 2 has cancelled the 2. So you have it there. So the equation is balanced. So here now, 2 times 2 is 4. 2 times 2 is 4. Hydrogen is balanced. Then this 2 times 2, that's 4 oxygen. This is 2 oxygen plus this 2 oxygen, that's 4. Equation is what? Balanced. Then the next one is potassium trioxochlorate 5, which is KClO3. It's a solid. When you eat it in the presence of manganese 4 oxide, it gives you potassium chloride. We don't just write equation, but something must have happened for us to write the equation. Plus what? Oxygen gas. So this topic, this particular one is under oxygen and its compound, SS2-10, when we'll be talking about laboratory preparation of oxygen. So then to balance this equation, potassium is 1 here, potassium is 1 here, so potassium is balanced. Chlorine is 1 here, chlorine is 1 here, chlorine is balanced. But oxygen is 3 here, but oxygen is what? 2 here. So what number can I put here? That when I multiply with these 2, will give me 3. What number? You can do some abracadabra. I want to put a number here. That number is X. I want to multiply it with these 2. And I want to get 3. Very simple. This one is now 2x equals to 3. Then what is x? X will now become to 3 over 2. The number is 3 over 2. And 2. So if I have 3 over 2 times 2 over 1, 2 cancel, that's 3. So the equation now is what? Is balanced. It's balanced. So this 3 already, I have 3. Or if you don't like it like this, you can use the denominator to multiply through. You now have 2KClO3, which is solid, equals to what? 2KCl aqueous plus what? 3O2. Why am I having 3? You already have 3 over 2. You are multiplying 2 by 2. So 2 has cancelled 2. So you have 3. Equation is balanced, my dear. So this is 2 potassium, 2 chlorine, 2 chlorine, 2 times 3 is 6, 3 times 2 is 6. Equation is what? Balanced. Then the next one is calcium trioxocarbonate 4. Thermal decomposition of calcium trioxocarbonate thiocarbonate 4. What do I do there? Calcium thiocarbonate 4 is CaCO3, solid. When you heat it, it gives you calcium oxide and what? Carbon 4 oxide. So what do we have? Is the equation balanced? Yes. 1 calcium, 1 calcium. 3, 1 carbon, 1 carbon. 3 oxygen, 1 plus 2, that's 3. Equation is balanced. So that is that. Now, we also have a type of reaction called double decomposition reaction. We have another type 3 now, double decomposition reaction. Double decomposition. Here in this one, A plus B will give me A plus B. Okay, sorry. AB plus CD will give me AC plus BD. So they interchange their part. A has combined with what C and B has combined with D. So they interchange their radicals. Example. The reaction between potassium chloride and lead 2-trioxonitrate 5 is a double decomposition reaction. Now, what is sodium chloride, potassium chloride? In our compound, you can visit our previous videos on compound to know how to write the formula for potassium chloride. Potassium chloride is KCl and it is aqueous, it can dissolve in water. All these aqueous S is not compulsory. As time goes by, you begin to know why we are putting it. It's not compulsory. So plus lead 2-trioxonitrate 5. Visit our video where we talk about compound and see how we got the formula for PbNO32. Now, we want to interchange. Now, what is happening here? Potassium will combine with the NO3. And don't forget, potassium ion is K+. NO3 is minus. So when this one is K1, NO3 1. 1 comes here, 1 comes here. So answer becomes what? KNO3, which is aqueous. Plus, now lead wants to combine with chlorine. Lead 2 ion is Pb2+, while chloride ion is Cl-. So this is Pb2, Cl1. 1 comes here, 2 comes here. So you now have what? Pb, no need of putting the 1 that is coming down. Then Cl what? This 2 is coming down, Cl2. So this is solid. Now, then to balance this equation, what do? Potassium is 1 here, potassium is 1 here. Chlorine is 1 here, but what? Chlorine is 2 here. These 2, I will come and put it here. But because I put 2 for potassium, for chlorine, it has also affected potassium, I'll put 2 here to balance the potassium. So already 1 lead is here, 1 lead is here. NO3 is 2 here. So these 2 has made this NO3 to be 2 also. The equation is what? Is balanced. So that is that under double decomposition reaction. So we can also have some other organic chemistry reactions like combustion reaction. Combustion reaction means A plus O2 equals to, let's say, AO2. So this is, you are burning something in the presence of oxygen. So you can give you AO2 or AO, it depends, or AO or anything. So e.g., combustion of propane is C3H 3 times 2, 6 plus 2, that's 8. This propane is a gas. Plus oxygen, oxygen is a gas also. Then it's going to give me carbon 4 oxide, CO2, and water. So that is it. So carbon here is 3. So I need to put 3 here for carbon. Now, the 3 I put there has affected my oxygen. 3 times 2 is 6. And here I have 2, so I can put 3 here. 3 times 2 is now what? 6. But my hydrogen is 8 here. And my hydrogen is 2 here. So if my hydrogen is 2 here, if I put 4 here, I have 4 times 2, 8. 4 times 2, 8, but my oxygen has been tampered with. Here and I have, for oxygen I have 3 times 2, 6, plus 4, that's 10. I have 10 oxygen here. And here I have 3 times 2, 6. It's very simple. It's just to adjust this 3. What number will I put in? That's 5. 5 times 2 is what? Is 10. So that is that. So now, let me just give you one statement here that will help you. Yeah, that statement is balancing of chemical equation is done by trial and error. So it is compulsory to balance a chemical equation. Why? Since the law of conservation of mass as stated by Dalton states that during ordinary chemical reactions, atoms can neither be created nor destroyed. So you cannot create atom, you cannot destroy atom. So the number of atoms you begin with at the reactant side must be equal to the number of atoms you finish with at the product side. If not, you would have created or destroyed atoms. So we are going to stop here for today. See you in the next class. I remain Afe Ademola Johnson. Subscribe, put your questions in comment sections, share the video. God bless you, and bye for now.